In this video, I am going to take the limit of three different functions using the properties of limits. So this first function, x squared plus 3x, we want to take the limit as x goes to 2. So we can recognize x squared plus 3x as a polynomial, and so we simply plug in our 2 into our polynomial. So that's going to be 2 squared plus 3 times 2, which is 4 plus 6, or just 10. Okay, the second limit is uses more properties. We're taking the limit as x goes to 4 of the square root of 3x plus 2. So first we recognize this is the sum of two functions. If we have the limit of the sum of two functions, that's the sum of the limits. So we rewrite this as the limit as x goes to 4 of the square root of 3x plus the limit as x goes to 4 of 2. Now the second part is easy. This is just a constant, and so this limit is just equal to the constant 2. First part, we have to use the property of the nth root, which means we can take the limit of the square root of 3x and turn that into the square root of the limit of 3x. So let's rewrite that. That's equal to the square root, the limit as x goes to 4 of 3x plus 2. The limit as x goes to 4 of 3x, that's a polynomial. We can plug that 4 in, so we get 12. And so this is simply the square root of 12 plus 2. Okay, this last limit is a quotient. If we're faced with a limit of a quotient, we need to think about what happens to the numerator and what happens to the denominator. So we're going to look at those two limits. Limit as x goes to 2 of x plus 2. That's simply, this x plus 2 is a polynomial, so that's simply plug in 2 and we get 4. And we can do the other limit. The limit of the denominator is as limit as x goes to 2 of x minus 2. X minus 2 is a polynomial. We can plug in 2 and we get 0. And so we recognize the numerator is a constant. It is defined and is not 0. The denominator, the limit of the denominator, is defined and is 0. And so by our last property of limits, this limit does not exist. Does not exist.